So I didn't get anything done on robots this week, but I might have mentioned on the meeting last week. If not, I was mentioning to Al privately that my garage door is going to get replaced. And after the third attempt, they did actually replace my garage door, and I now have a garage door opener. And it turns out it's a Chamberlain. Here, let me I pull it up right here. Say share, share, share screen, and screen two. We'll see if that works. So anyway, this is what I got. Oh, I was complaining about my format last time. I see it's right. So let me do this. So if anybody's watching the video, you'll see that the screen didn't shrink down, and it's just got this little picture that may or may not move around when I move with my cursor. Anyway, this is the garage door opener they put on, and it says it's a quiet Wi-Fi garage door opener with wireless keypad. And if you look in the picture down here, it's got this thing right here is on the wall. So instead of having the old original like doorbell push button, it's got this fancier thing. So this up here is a button that opens and closes the door. And then down here, let's see, can I zoom in on that? Well, doesn't matter. Anyway, there's a button there that turns the light on and off. It's got lights on the two sides of this thing up here. And then there's an LED there somewhere that apparently it's some kind of status LED, and probably if you put your foot in front of the sensors, that light goes off, or if something's wrong, that the light might blink. So it's got that, and then they gave me these two wireless remotes. So like normally people keep them in their car, and I'll just keep mine in the house since I don't plan to use that that way. And then it's got this other thing you can say you can download the Wi-Fi app, so you can put it on your phone, and apparently from your phone you can say open the door or close the door, and maybe it'll give me a status on whether the door is open or not. So I was saying, the whole thing was I thought it might inspire me to have my robot get to the point where it can open and close the door on its own. And I was saying, well, you can put a relay across the push button on the wall. Well, it looks like it's got two wires going into this box that has several functions. So apparently it's some kind of electronic communication, not just a push button out there. And then somebody else on YouTube was saying, here's what I did. And they just took one of the get better pictures down here. Let's try. Well, that's not gonna let me zoom in on it. Anyway, this box here that's got the two push buttons and an LED. It seems like that'd be a pain to try to figure that out. And then on the left here, the two wireless remotes. They basically just took one of these wireless remotes and soldered the wires across the push button and ran it out hooked up to a relay. So they're doing exactly what I said you could do. And for some reason, in the YouTube video, they mounted that right next to the garage door opener. And I thought, well, what's the point of that? It's Wi-Fi. You can put it in your house next to your computer and have it just click the relay there, and then that would open and close your garage door. So that would be an option to do it that way. And then since this MyQ app that'll run on a cell phone, and somewhere it says you can run it on, it says you must have a cell phone or a tablet or a laptop. So theoretically, I might be able to load this on a laptop and be able to open and close the door and get status. And I haven't tried any of that yet. I was just annoyed after as long as it took to do it and all the screwing around I had to do to get it ready. So I haven't looked into it anymore yet, but that might be an option too. So this somehow the garage door opener itself connects to your home Wi-Fi network, and then whatever app you have then connects to your Wi-Fi network and then talks back and forth. Which brings up an interesting point: is as cheap as electronics has gotten, if you want to add Wi-Fi to anything, just go out and buy one of those ESP32 modules that's got Wi-Fi and Bluetooth. You just hook it up, and you can basically control anything you want. You have it connect to your home network. So that's basically what they've done here, I guess. They've just got something built in that is smart enough to, connect into your Wi-Fi. And then theoretically, once you got that, from anywhere in the world, I could say, open my door if I wanted to. So that might be, rather than trying to solder wires on one of these little boxes, if I can just connect it to it through the Wi-Fi, that might be a way to go on that. And essentially, they put in a new garage door that's like I guess stamped aluminum or something, and they put in this better pictures of this thing. Oh, here's another annoying thing that I noticed. Now you can get Amazon Key in garage delivery. So now they've they've connected with Amazon, so Amazon can come in your garage if they want. And they all as this stuff gets, I can't think of the correct term here. As it gets more annoying, they tie all this crap together, and some one of these days, they just drive a big truck down the road and push a button, and your entire house opens up. They just clean your house out and move on to the next house. This is the way it's going to happen. But so anyway, back to the point. They did install my garage door. I do have a garage door opener. If I get the ambition, I can put on my list of things I'll never do is to figure out how to get my robot to open and close the garage door. And I guess other than that, oh, one more cute story. They started off, one of the first things they did was taking the old door off, and I was just kind of, I'm just coming out of the house, and they had been working on it for a while, and I heard this big boom. I looked up. Apparently, they lifted the garage door up all the way, disconnected the springs, and then let go of it. They just slammed down because the old door was made out of wood, so it was like, I think it's like a foam core with some kind of wood over the top of it, and the new ones is lightweight aluminum or something. And the guy's comment was, "Oh, that's a heavy door." I'm just glad nobody had their toes under it when they dropped that. So I did notice when they did the garage door next door that they didn't drop it like that. So I think they wised up and didn't let it get away from them. So that's my story of what happened this week. It's taken like three weeks to get around and install this thing because I was dealing with incompetent management, we'll say. So finally they got around and got this done, and that's where that's at. I thought I had a second thing I was going to talk about, but I can't remember now what it was. So I've been sitting here like for 10 minutes trying to remember what it was, and I can't remember. So we'll just leave it at that. And I guess I'm really stop sharing. So I guess I'm done.
It'll come to you once I start. Well, I certainly look forward to the day where your robot is driving in and out of your garage. Oh, let's see. So I created this path and tested this path. Some success, some failure. Uh, as a reminder, when we were running these paths a while ago, we sort of determined that the Larry's Pure Pursuit had a bit of a speed, well, at least for me, seemed to have a speed issue. It would run okay at, say, half a meter a second, but if you got up to a meter a second, it got wavy. And that's what happened again. So the bit of success is it did run the outer perimeter, didn't hit anything. It did go around this circle as an obstacle, and it did make its way around that. But the speed control was, um, I had in my particular configuration, I've got a servo and I give it one particular setting on the servo and just let it go. And this property has some, you know, up and down in it. It's not perfectly flat. And speed control with one servo setting is just not going to cut it in this particular landscape. So I've got to go back and implement PID and in my transmission control, which controls the speed. And that's where I'm at a high level.
Do you
Um,
do you have any plots of you say it doesn't maintain the speed? Do you have anything that shows how much the speed varies? And
I have the ROS files. I don't have a plot handy to show that, but I could. Um, I'll I'll make some plots and
because I was always assuming that on your hydrostatic transmission, whether you have a hydrostatic or a manual transmission, basically it's going to have a fixed speed ratio. Like, and in fact, since you have your RC servo sets it to a speed and leaves it there, it seems like that should act like a manual transmission. In which case, it is just up the governor on your engine to hold your engine RPM at the same speed all the time. So I just assumed that would work and that it shouldn't, your speed shouldn't vary as you drive around. So it'll be interesting to find out, what you find out there. by looking at the plots, doesn't vary a lot. And you could even look at, say, you pull up your IMU stuff and look at the angle, so you can see if you're driving uphill or downhill. Might be a interesting thing to look at, and then compare that to the speed of the thing.
Yeah, so I don't know if my engine has a governor on it or not, but I mean, so going downhill, it's going to go faster. Going uphill, it's going to go slower. Um, I mean, that's literally what I experienced in driving this perimeter. Um, so it
And
might
my
be,
my assumption is any lawnmower, most we'll call them industrial vehicles, will have a governor on the engine. And that's why you're also talking about, right now you got a piece of wire on your engine throttle, and you're talking about the fact that it takes so much force to pull on that. Well, that's because you're pulling against the spring on the governor, is why that's happening. So, and if it could be whatever you're doing there by trying to wire that off, maybe you defeated the purpose of that. But I'm thinking that probably has a governor, and the governor is probably working. Otherwise, as soon as you start the thing and drive into the grass, it's going to bog down, and just from the blade cutting the grass. So anyway, it'll be just something to watch for and see. But I don't think you should go to a lot of trouble to control the speed until you get that figured out. If that's, if the, figure out what that's actually doing there.
yeah, so the throttle is wired, and all I did is wear the long cable deal. Instead of the cable, there's a wire there. And um, so there's that of the things that I've taken off the tractor. That's the least modified as far as the engine throttle setting. Um, but anyway, let's see. So then I was going to implement a PID on my throttle. And so I built this little plan where I would just come down here, make a left, come back up, make a left, make a right, make a left, and end. Um, so I built this little Jupyter notebook to take as input this point, and these other points are calculated. So I tried to run that, and the steering, the left-hand turn was making the furthest left turn wasn't where I needed it to be. It was making too shallow of a turn. So where the tractor, if you were driving it manually, could turn in about 2 meters, 1.3 meters, I think is what it was actually set at. Um, the steering was off, and so I had to go in and adjust the left and right extremes. And I think I know what the cause of that was. I think it has to do physically with the gear that's connected to the potentiometer. So I got that reorganized. Um, so in let's see, what's that setting? Yeah, so the left limit was set at, well, so I've changed my left and right extreme points to be 490 and 3210. They were not terribly off from that previously, but it changed it a little bit. So I think that's on I think I'm still dealing with the repercussions from that, because now my motor controller um, I have one of these Citron MD30 motor controllers, and on that motor controller is a couple of LEDs that show which, so the output, this is the output side, this is the power side. Can't really see it, but there's an LED, there's two LEDs here, one for the B channel and one for the A channel. And the A channel is staying illuminated constantly, which means this DIR pin is getting set. I forget whether it's low or high for the A channel, but so I got some sort of software problem that's, or could be a short in the wires are my two hypotheses. So that's where I'm at the moment, is trying to debug why this motor controller seems to be stuck on driving the A channel high.
But does it actually function?
Yeah,
Or
I
is it
took it off.
just the fact that you see the LEDs on?
Well, it drove the steering hard left and wouldn't come off of that no matter what I would do to the radio control.
Oh, okay.
Um,
I thought you were saying it was working just fine, just one of your LEDs was on. That
no,
that was the
that,
problem.
yeah, I messed up. Um, so anyway, that's where I'm at the moment, just trying to debug my steering control logic and figuring out why that seems to be all screwed up at the moment. And by screwed up, I mean when it's disconnected, when the, so I took this off of the tractor and brought it home, plugged in 12 volts, and the AB light didn't come on, which is good. And I'm in the process of connecting it to my spare ESP32 to drive this to see if it's going to drive like it's, and by drive, I mean voltage is applied to A and B separately depending on the settings here. And if that's the case, then I think I've got something um, either physically wrong with the wiring for these, or something's goofed up in my software. So anyway, that's where I'm at the moment, is trying to debug that.
Yeah, if it were still on your lawn tractor, which you said you took it off and took it home with you, but if it was still on there, you could have just pulled the wires from that connector on the left there. And then I assume thing would have calmed down, and that would also tell you whether it's the wiring or the software. Because if it's the software telling it to do the wrong thing, then pulling the wires off, then the board will just go back to, the board will just calm down like you say that it's doing right now.
Yeah, that
Hmm.
I seem to get out in the field and then I get all flustered when something doesn't work, and I sort of need to sit with it for a little bit to figure out the debug steps. So
Yeah.
yeah, so anyway, I didn't do much debugging in the field other than say this isn't working, take it off.
Um,
Anyway,
so when did it start doing this? Is that,
after I changed this left extreme and right extreme.
so it was working after the mouse was chewing on it, and then you changed the numbers and it quit working? Is that basically what we're looking at?
Yeah.
So it's not a mouse problem then.
Well, I don't know. The mouse, I guess not. No, it wouldn't have been. And so there is a potential. Um, it might be a version control thing. I might have changed something in this code and then re-uploaded it when I changed these, and that's stumped on something. So that's this. I don't remember what I would have changed in it, but there is some possibility that it's a version control. I uploaded the wrong version, but I just got to fight my way through that. But now that you mention it, I don't believe it's a mouse chewing through a wire problem.
So speaking of mice, how did your sensor turn out? You had a problem with your sensor, and then you were going to look at the wiring, or how did that all go?
I haven't found any more. Um, I haven't found any more issues, and I replaced the wire that the mouse ate, which was the 12-volt power to the USB hub without without issue. Um, so I'm it feels like I'm getting closer, but I keep falling into these potholes that I got to dig myself out of.
So
When I-
so your sensor that was not working, is that working now, or is it still broken? It was a wheel sensor, I think, is what you were talking about before.
oh, you know what? Um, the easiest solution fixed it, and that was, um, I mean, I checked the USB cable and whatnot. Um, all I needed to do was reset my Teensy. There's a reset button on there. I pressed the reset button, and it cleared the I2C error. Um, and so that particular error um, went away, which was nice.
That's something you have to tear it completely apart to get to the reset button, or is it out where you can get to it?
It is um, it's available. I can reach it with a little bit of finagling. I don't have to tear it all apart. Now that's on the left wheel. On the right wheel, my second version of the holder for that, it was fully enclosed, trying to make it more waterproof. So that one is going to be a little bit of a problem if I ever have to reset it, because I can't physically get to it without basically taking it off and unscrewing it.
So just cycling the power doesn't reset your board? Or is this something else that it's doing?
Well, it did. So I cycled the power multiple times, and the I2C communication error continued. With power applied and pressing the reset button, the I2C error cleared. So I don't know what down in the bowels of the teensy is different between um, powering off and on versus pressing that reset button, but something obviously was different.
Does that get its power over the USB, or do you have separate power coming into that board?
Powered by the USB.
Okay. If that's the case, you should just be able to unplug the USB cable and plug it back in. And is that what you meant by you recycling power?
Yes, because the USB hub has on-off switch for each of the USBs,
Uh-huh.
and I would cycle power there by pressing the on-off button, and then I would physically disconnect it, take the USB cable out and plug it back in, and that would not clear the I2C error.
Huh.
But pressing the reset button on the physical board did clear the I2C error.
The other thing you might look for, you'd have to pull up the teensy documentation and see if the reset comes out to one of the I/O pins. And if it does, you can just run a wire up, put a reset button where you can get to it, right on your housing, just put a little like a snap switch on there or something.
Yeah, that was in the back of my mind too.
But 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 look at it real hard, because you might have a pin that's labeled reset, but make sure it's really is the reset that's connected to that push button, and not like an output or something else. So you might have to look at the schematic, or just because a pin is labeled reset, check to see what it's really doing before you start connecting a lot of things to it.
the other thing with a couple other changes that I made, the GUI that I have, where is that? Um, So I added a couple more data elements to the GUI so I can see it without having to do some sort of ROS topic echo. So I displaying on my GUI the steering potentiometer, the steering set point, and then the steering variable called steer effort, which goes into well, it's the output from the PID. Because I was trying to say, what are you sending the motor controller? It's just helping me make it a little bit easier to debug versus doing the ROS topic echo commands and having to open up different windows to do that. One other thing that I'll just mention briefly, it's sort of unrelated to robots specifically, but I wrote this little thing to go out to my history file and write my history to, oh, that's the search. That's not what I was going to show. You know how you can do a history and do a grep to search your history?
Yes.
Well, you had told me sometime before that you periodically save those off so that the history doesn't roll over. So I wanted to do the same sort of thing, but I put it in a spreadsheet so that what that looks like is, I've got the date and time that I did those statements plus all the statements going back for this particular machine from now until back to December of last year. So that was another little debug step that was sort of helpful. Anyway, that's what's been going on in my neck of the woods. Frustratingly slow, frustratingly slow.
I guess I don't have anything else. You done?